Welcome to our FDP session on electric vehicle components and architecture. I'm Dr. Thirumurugan, host for this session, and my colleague Dr. Godwin as a co-host. I'm honored to welcome all the participants for this session. Please join me in welcoming our speaker, Dr. Bharatiraja, who has agreed to share his expertise with us. Welcome, sir.
Yes, sir. Welcome.
It's my pleasure to introduce the speaker. Dr. Bharatiraja is currently working as a professor at the Department of Electrical and Electronics Engineering, SRM Institute of Science and Technology, Kattangothur campus. He is also heading the center Research Center of E-Mobility, established at the SRM Institute of Science and Technology. And he has authored more than 180 research papers, 10 book chapters, and he has 8 IPR patents. He also made 2 technology transfers. He is an award recipient of BASE Fellowship, Young Scientist Fellowship from TNACST, and also is one of the world's top 2% scientists in the year 2021 and 2022 consecutively under the energy category. And also he has received government-funded projects total worth of 15.65 crores, including SERV, DST, TNACST, etc. And he is a senior member of IEEE, IEA, IET, and various professional bodies. He is also a member and mentor and advisor for many government bodies and private companies. This is a very short resume. He has a vast experience and expertise in this particular field. Now I hand over the session to our speaker, sir.
Yeah, I'm happy to see, first of all, 94 participants, The last 1 month, almost 2 months, I'm giving various workshops and the participant strength is very less, but I congratulate and as well, I give my best wishes to the Crescent team to bringing huge population, so because any speaker, when they get motivated, when they are, when the more populations, is available in their presentation. So in that I congratulate and as well, I congratulate the team who are procure, the facility through the ATAL FDP, especially the area is booming in our electrical engineering, it's electrical mobility. And also I thank the professor and HOD for giving this opportunity to spend my time and my experience today. So quickly I go into my presentation. Probably my presentation, mainly I'm going to cover chargers, but I would also take an opportunity to showcase to the the research and the e-mobility and especially and what are the the exercise we are doing in our center and how our center will be useful for other colleagues who are working in different universities and what are the benefits for the research scholar in our center. Probably I'm going to cover everything in this 1.5 hours. So many of you know about it. SRM University Kattangothur is actually located in towards the GST road. Maybe the next Crescent, it's 10 kilometers. You can reach our university. We have multiple departments, including law, medical science, and all about. We have 192 beautiful acres. It is located in on the GST road. So our center now in the construction stage. So you can see the picture. If it is, assume that it is going to become like this. Probably 3 floors were constructed and we are all occupied. 3 floors and rest of the floors are getting constructed. You can see the right side. This is our lab. So as you can see that this is something different lab. I am just prepared myself that what are the research is going to happen for the past 5 years and what is going to be happen for the next 20 years. Considering all, we build this center. One of the evidence that we made a track within the center. This is actually not an ordinary track; it's a wireless charging track. You can able to charge your vehicle while vehicle is moving. And also this we are using as autonomous vehicle track to validate our autonomous system. So basically, these are the major facility we have with us. we are almost covering all the electrical vehicle subsystem. For example, we have wireless charging track and EV charging discovery emulator, which will be normally not test the any kind of charger. And we have a 50 kilowatt dyno, and we have a Opel RTL with the PHIL simulator. You can lively grid connect your grid and you can simulate. And we have a large size of battery pack testing and cell testing. And of course, we have some of the power supplies and we have D-space controller. Especially, we have a Calexio controller. It is having a lot of paralleling processing unit and where you can do an autonomous vehicle platform. And we are also working with the hydrogen powered electrical vehicle. And we have a very good capacity of power scopes and power analyzer. So whatever the facility here I have created, it's all probably mimic the ARI facility. So meaning it is beyond academic and any electrical vehicle components such as motor and charger. When you come into market, it has to be get some certification. So my instrument, whatever I have, it is equivalent to available with the ARI. So anybody testing in our center and directly they can go and get certification from the ARI. So that kind of capacity we built, and this is my project only cover with the electric mobility. So I have completed almost some of the project in nearly the worth of 1 crore. So currently I am running these 3 projects. One is DST Purse, it's close to 15 crores, and then another Spark project is 75 lakhs, and another technology development program. It is about 40 kilowatt charger, which means a motor. So you can see this is you can easily understand that how we made this center for wireless charging. You can see just open the tiles and in the track, and you can also see that calibration how we are doing with the model vehicle. So, and these are the hill simulator, and these are the Opel RTL grid emulator, and you can connect these two, and you can easily validate the live practical charger and practical scenario what's happening in the grid. And this is our dyno where you can connect your huge size of motor, we can test it, and this is our battery pack facility. And also we have testing facilities, and I think somebody is returning in the screen. Okay, so this is our autonomous vehicle, and this is our motor testing calibration unit, and these are the hill emulator, and of course this is D-space facility, and this is our battery emulator. And right side you can see that this is a fuel cell development. We have lab scale model and as well as car scale model. So this is a rough idea about what is our center is having, and probably we can see some more things as well. So actually, sir, what happened? This screen somebody is writing. You can understand what somebody is writing here. Okay, it's fine. Yeah. So I think you might have attended 2 days different lectures with respect to difference between the electrical vehicle, why the common people should have electrical vehicle, and what is the grassroots level of understanding. So it's my understanding there are 2 people are buying electrical vehicle. They're thinking in their mind that first of all cost, and second one is maintenance, and third one probably whether we are free for environmental friendly vehicle or not. So this is what basically. So considering these 3 points, of course, definitely electrical vehicle is a better choice. But there are technological issue, and there are availability in the supply chain. We are not able to get a proper battery. Because of that reason, there are some accidents are happening. But that is not only vehicle maker issues, and it might be the issue of so many factors like climatic conditions and how we are charging our battery, how we are handling our battery. All together, it is taken in a choice whether you are choosing electrical vehicle or not. If you ask me that if I have electrical vehicle, of course I don't have an electrical scooter. Still, I'm using the ordinary petrol vehicle only. But of course, my next choice is going to be electrical scooter, no doubt. I'm not able to change the screen. I don't know why. Okay, so let's go with a very simple electrical vehicles architecture, because the title itself is architecture. So I just wanted to address something. So if you take any electrical vehicle compared with the IC engine, there are three major components. One is battery and the inverter, which will be drive the motor, and finally we have a motor. So apart from that, the battery itself, there are batteries mainly used for the driving the motor. It's called traction batteries. And of course, those batteries are different capacity. But whereas you come to your motor, the motor needs some kind of voltage. And of course, the inverter has to be serve that voltage to the motor. So we need some DC-DC converter in the motor controller side. And of course, the same DC-DC converter we need in the charging side. Then we need a motor and we need a power converters and charging ports. Maybe you are afford to have an onboard charger. Of course, that power electronics board you need. And you should have some controller. Normally, we call it as a VCU, vehicle control unit. Then some auxiliary battery, which will be served for, lighting and other aspects in the vehicle. And finally, thermal is one of the major concern in the battery and as well as the motor side. Maybe motor side, we can design the motor according to the thermal runaway problem. But considering the motor battery side, definitely we could go to the separate cooling system. And some transmission is nothing but a wire harvesting. So the electrical wiring also very important, low voltage wiring and high voltage wiring and sensor based wiring. So all together, electrical vehicle is normally getting architectured. So coming to in a country or ideology to taking into electric mobility in the road deployment, it is not only a vehicle segment, it is also covers with the charging infrastructure and some kind of supply chain. So take it as an example as in India. So we are very good in automobile. There is no doubt. I'm not talking about electrical vehicle. In IC, petrol and diesel itself, we are very good. We are making almost all the part of world, who are maybe, like if you take Toyota, if you take, let's say Nissan, you take an R&D like Renault Nissan, everybody they're having the factory and R&D center in India, particularly in Chennai. We are lucky to have this company. So electrical vehicle also, again, Mahindra, Switch Mobility and Tata Motors, and people are already manufacturing the vehicle. And there are new people are also coming in. So there is no doubt the electrical vehicle segment, we are very, very good. Whereas compared to the charging infrastructure and, the supply chain, the charging infrastructure, we don't have a sufficient charging infrastructure right now because there are multiple reasons, in the universal chargers are not available, and every car maker they're suggested to go for their own making charger or some kind of connectivity issue and grid availability and of course the land availability. So everything is put together in creating a lot of struggle to have a lot of charging stations in India. But in my view, in supply chain is even worse because, frankly speaking, many components are coming from China. So they are flipped compared to our technology. We are just now started. Especially, I'm looking into battery side. Battery needs silicon material. Of course, people are now thinking about the sodium materials for the sodium batteries. You see, the silicon-based battery cells are coming from abroad, and we are packing and using it. India is a large populated country. Suppose you assume that everybody having electrical vehicle, at least 50% having electrical vehicle. A day, the electrical vehicle, when your battery get degraded, you have to exchange the battery. So again, you have to blame another country to give the battery. So again, this country will send the batteries, but they will increase the price like anything. Then what we can do? Just take an example that COVID time, how the COVID vaccination gets peaked because we don't have any indigenized vaccination. But once in time the Covaxin is identified, then we are getting it very easily. Even every Indians are afford to use it. So supply chain is very, very important. The supply chain is something like not only for the battery, silicon materials, power electronics components and other magnets for a motors, right? So in that way, we are not actually good as of now. So let an example of supply chain about how it is the battery, we start from mining and it is coming to the electrical vehicle. Again, that has to be recycled and it is go for a reuse. So that is basically called supply chain. Not only for motor, electrical vehicle, once it started, we have to see that an alternative solution for power electronics components and sensors and other kind of subsystems, how we are going to recycle and how we are going to indigenize that metal lots. So India transforming towards the electrical vehicle, yes, of course, we are taking a lot of steps. Government is a lot of steps, and each and every individual is also thinking to migrate into electrical vehicle because of a lot of advantages are there. But if you look at what our country is doing into it, probably you might have understand about the National Electric Mobility Mission. It has been created during the COVID time. Due to the COVID, next 2 years is not worked properly. But the last 2 years, they have taken a lot of initiative, especially research funding also. Recently, there is a separate, program is called it as mega project. So everybody might have came to know that this is a huge funding given by the government and creating some research facility within the institution, right? So what is that India context to take it forward into this electric mobility is that we should have owning systems like motor, power electronics, and digital circuits. So there are already some startups are entering into market. When one of the SRM students in my lab who worked, they are raised about 250 crores from Forging. They are manufacturing motor now. They're giving to Tata Motors and ALR Motors and Maruti and even Renault Nissan. So it is understand that there are newcomers are coming and new age people like ATAR and all. But still there are components we are outsourcing like power electronics and digital circuits. And provided charging infrastructure, as I already mentioned, then the batteries and then cost-effective batteries is another very important because we have to cut down the cost. And we should also see the alternative solution to replace the battery. Maybe you can consider as fuel cell or any other new technology in the energy-based solutions we have to focus on. And finally, the renewable energy availability in India is very, very very much available. So we have to see that how these renewable energies to be connected within the charging station to avoid the grid penetration. This is what the challenge is in front of us. All our faculty and student community, we have to concentrate to create a technology for our country to develop respect to this national electric mobility. So UPI government is actually taking a lot of initiative. So there are multiple ministries are now working on. So you can see this. India has made a target at least 70% of personal vehicle, the vehicle which is used by me and you and Ola and Uber and so these kind of category vehicles supposed to be an electrical vehicle. These are the ministries are working, especially Niti Aayog, Heavy Industry Ministry, Road Transport and Urbanization, and Power Ministry. So all are working towards that. Let's see some kind of geopolitical issue. Now, there is a tug of war between India and as well as China. Maybe you can take it as Elon Musk is a separate way, separate first wing that only Elon Musk is doing a lot of things in EV, including autonomous vehicle in US. But if you target about EV, then there is a lot of subsystem like charger, motors, and other power electronics converters and all, right? So the major components is coming from China. But if you see 2030, the real game going to start because India also taking a lot of initiative. There are a lot of Indian companies and a lot of foreign companies made an investment to create this motor and electrical vehicle infrastructures and everything. So in that to the case in 2020, the China, whatever they are manufacturing, they won't get a place to sell because India is actually procuring 90% of EV components from China. So slowly we are improved our own indigenization component level and system level. So of course, later India will be a master again in automobile and we will sell it to many people. So there are a lot of articles saying that, 2024, in the beginning, whether India can beat or not. There are few companies. Here, this is one company from ATAR, like the students from IIT Bombay and students from IIT Delhi. They are created some kind of electronic controller board. This is the next generation board. It is beating even China technology. So there are a lot of kind of scannings are there, like, some predictions are there, whatever. It's end of the day, it's like, the recommendations of government and all, it's saying that this is the final picture in 2030. So according to my perception, the India will be a front runner, then China, then the rest of the European countries like Denmark and Sweden and all. So This another policy that the 50% of fossil fuel import also we are going to reduce. So these are some of the samples around our country. You see, this is something near Uttar Pradesh. You can see the green color autos. Even some days before Chennai, we used to have a share autos, right? So those share autos, 10 people are able to travel. Now this UP government has announced the electrical vehicle can have a share auto. So now you can see that close to 2,000 share autos are in UP now, and they are very much used it. And this Ministry of Heavy Industry, they're doing it. And another story is that this Elon Musk, whether Elon Musk coming to India and how they go to China and what is the supply chain and so many things. Again, so many articles. What is the investment is going to come India next month? Investment will come. Our Prime Minister went and meet Elon Musk, and India gets on Andhra Pradesh to set up the factory. So many things are there. It's all going on. But anyway, the final fact is that the future car in Tesla, probably a car is called the ES481. It's a purely autonomous and self-driving electrical vehicle. Is going to be manufactured in India. The announcement will come very soon. So the supply chain, as I already told, it is a raw material, subsystem, component level, and assembly level, and what is the life and EV charging infrastructure, grid connected components, and what is their life cycle. So this is one thing that we are little bit lagging, but the point is that we are going up and fast. So just take a small example that what is the charging first of all. So if you take for electrical four-wheeler, these are the charging systems are available: conductive charging, inductive charging, and battery swapping. So conductive means is a wired-based charging, and inductive means is wireless charging. It is not yet grown. Probably after 5 years, and people afford to use it, this technology. And battery swapping, basically, people are not using it. Maybe in Delhi, Noida, and in southern part, some of the northern parts, they are using a battery swapping for auto. But it's okay for auto, e-rickshaw, but it is not offered for car and truck and all. Basically, AC charger and DC charger. Again, AC charger, it's an onboard charger. In India, we call it as AC001. It's CCS2 charger. And DC also, there are different level will be there. So one thing you have to keep it in mind that electrical vehicle, there the problem is how we are going to make it into fleet management. Fleet management sense that we have own car, we have a Uber vehicle car, we have a loaded vehicle and truck and buses and all. And of course, offices also using the car. Okay, so the problem is not a vehicle. The problem is charging station. So it is something like Uber and Ola, maybe they can build their own charging station. They will get charged their own. It is called it as private chargers. Suppose government taking initiative, putting up a different charging places, no matter whether your vehicle or it's a Ola vehicle, whatever it is, they will come and get charged. And of course, the buses and everyone probably charge in own depot or in any common place. So the problem here is that the fleet management, as I already told, there are a lot of studies are going in India. The problem is India is huge populated country, civil structures, though we have created multiple bridge and we have a very good connectivity of a railway station and all about, but creating charging station is a lot of problem will be there. Something like you can see here is a simple understanding. On demand of cab fleet is very easy because there are multiple cabs. They may renting their land and they some charging provider continuously they can sell their charging to the cab because every cabs for a day minimum 200 kilometers they are running and they can get charged, so automatically they can get a revenue. But whereas you coming to the public charging, there is no actually business model because sometimes we may go and get the public charging part and sometimes we may not. If you are not going into the charging station, then what is the cost of the land and rent of the land and what is the rent of the charging station and all these other employee, and this is another problem in front of us. So there are again a lot of studies are going in how to connect this. So generally, this is what the plan actually. I have captured some of the plan from the government policy website only. So basically, they may going to create some kind of a public charging facility, common charging facility, and capacity charging facility. So like capacity charging facility means it's very simple. There may be a common charging area. It is a multi-story charging area. Assume that Kurumpet Saravana store is there, right? They have a parking area, right? So likewise, they'll create, you go and park your car, go a shopping, then come and you will get charged. This kind of practices can do, but again, the investment is very large. Or else we can go like a public charging, like a bus stand. There's so many charging slot will be there. You can charge your car. There is a small park area will be there. You take a rest and have a coffee, then you can charge it. So as a kind of solutions and practices are actually taking place. But the problem is, you just look at this, the charging standards, the level 1 and level 2. So slow charging, standard charging, and rapid charging. This is another problem. So whatever the pictures and whatever the ideology I have shown before, see, in India population of the vehicle and road structure, the government studied and given a statement that every 3 kilometers in the city, we should have a charging station, not a one charging station, minimum 50 charging station in a place, so that we can avoid the penetration, assuming at 2030, 70% passenger vehicle supposed to be a electrical vehicle car. And likewise, every 25 kilometers in the highway, we should have a charging station, and every 100 kilometers, we should have a heavy charging station. Heavy charging station means truck, buses and all. So another problem in front of us, the charging level, slow charging, rapid charging, and standard charging. So standard charging only, nowadays we are all practicing. Rapid charging means quicker charging. When you go quicker charging, again, during that area, you have a transformer to handle it. Say for example, if you go for a bus charger, quicker charging in China and even Japan, what they're using, a 1 hour, the time for 250 kilowatt battery get charged. Suppose you assume in Guduvanjeri, near our Crescent or SRM near, if you put that charger, we will get a grid penetration, because that particular places, the total availability of transformer capacity itself is 250 kilowatts. So these are the major challenge in front of us, because our power line is 33 kilowatt and 11 kilowatt cables associated. So we should have a metering and civil work to be constructed. As I have told already, we have a lot of space to park the vehicle. So in front of us, there are huge local problem will be there. Of course, we are the researcher, we don't want to bother about it, but we also supposed to be know about what it is. So simply you should understand, a first table what I have represented, if you feel that you want to put a charging station, your installation cost only for the civil and some kind of marketing and all about, close to 20 lakhs. Then charging, these are charges are available, you have to invest. So close to 35 to 40 lakhs, you should have an investment to keep the charging station. So considering that, 1 unit you have to sell at least for 80 rupees, then only you can take your investment. Okay. So this is what the scenario in India. So these are chargers provider. Right now, they are handling it because they have a tie-up with the vehicles. For example, Tata Motor, they have a tie-up with Tata Power. MG, they tie-up with the Delta and the Dyna. So likewise, it's going, but there is no publicly affordable value. And of course, when you are thinking about charger, this is also important. So which means that user needs analysis, demand analysis for the grid side and passenger side. And we should have a dynamic modeling. When you charging your bus and heavy duty trucks, you should have a grid study with respect to infrastructure, because summer, when you turned on your AC, sometimes AC is not turned on because voltage penetration during the evening. You just assume when all are coming to home and 8 o'clock, they started to charge, then what is the level of electricity fluctuation we will get, just imagine. So this should be studied properly in each and every zone, sideways locations and everything. And finally, investment, we need a huge. It is not only government investment, it's also public and government mixed investment. So these are all the issues in front of us. I just skipped some of the slides. Okay. Now coming to this, generally in the overall picture of EV, so this chart maybe provide your understanding. So where we are now and what we have to do it. So as you can see here, EV is a single segment. It is there in the middle, but it's saying about different category. One is that pure EV, and it's a plugged-in EV, and mixed EV. It's called hybrid EV, and fuel cell also there. Then come to the next layer. It is all depends on power, lifetime, safety, cost of the vehicle, and what is the energy consumptions. And coming to the next layer, when you come energy, now we have only battery with us. So lithium-based batteries or any emerging batteries or any lithium beyond batteries like sodium batteries, and before lithium like lead acid batteries, also some buggies are using, right? And coming to the next layer, again, battery should be properly modeled or not. And those batteries are probably safe or not, that should be estimated. If it is not safe, then what is the health diagnostic? And of course, some kind of energy management also we have to do. Again, you come to the outer side, this battery to be charged, right? So that should be charged either wireless power transfer way or fast charging, or what is the density of the battery, what is the safety concern when you are charging, what are the sensors and chip you are using, what is the smart power electronics you used it, and what are the information of internet technology are going to use it. So all together decided for a charger to afford in any electrical vehicle. So it's a lot of challenge in front of us. Okay, fine. So now in broad, these are the area for researcher. So here after everything cover, we are going to cover in research side, right? So these are the broad area we are supposed to concentrate, be an academician. We can work on battery, we can work on motor, we can work on power electronics converter. The power electronics converter, neither charger or motor. Again, we can dedicatedly work on charger, how much of power you're going to give and what is the type of charging, CV or CC mode or CP mode, and whether it is wire charger or wireless charger. And finally, simulation, or you can call it as ICT, information communication and technology tools. So ICT means it includes ADA system, charging emulation, battery management system, even power electronics emulation, power electronics digital twin. So all we can work. These are the trust area currently we're supposed to focus on, those who are wanted to do research. So basically considering architecture, I think my previous speaker might have discussed with you a lot, but just I take an opportunity to take it how this energy management is going to behave. Basically, if you take any powertrain, we have a battery to drive the motor, that everyone knows it. But beyond that, we have supercapacitors also available. That supercapacitors help when the vehicles get regenerative. As you can see this figure also, there is a supercapacitor and as well as there is a battery. So normally what happens, that battery deliver the power into the motor, and when you are driving the vehicle, suddenly you are putting a brake, that amount of energy what is there in the motor that goes back to the battery, probably that's a theory, but the battery cannot quickly get that energy. So the supercapacitor only having the characteristics to store that quicker energy come out from the battery. So the supercapacitor is getting charged during the time when you are putting a braking. Again, when you go to drive mode, the supercapacitor getting an discharge and store to the battery, provided the battery also discharging to the powertrain motor, and those will be handled by energy management controller. So this is another one of the area the researchers can focus on. So now you go to the body electrical vehicle architecture. So I will showcase that how the vehicle body is structured. So as you can see here, take any electrical vehicle, there are 4 major components. One is the battery. Here, this is a powertrain. It is floor mounted battery. Then this battery includes, some battery management system and cooling system. And another one is nothing but a motor. So the motor is the next component. Then the motor has to be actuated by the controller that is there here. Then we should have a VCU, vehicle control unit, that is there on the back side or front side. So as you can see, you can see here, this is a skeleton model. So the battery is supposed to be built here. This is a portion where the battery is built. But anyway, you can see the motor, how is coupled. So this is a front wheel drive motor, which means the vehicle front wheel is connected a motor. So this is the axle. With the axle, we are connected the motor with the gearbox system. You know about why the gearbox is used, because motor is rotating in a high speed with the less torque. Suppose you want to reduce the speed, increase the torque, you can use the gearbox. Normally gearbox is 10:1 means, so 2000 RPM motor, if you put 10:1 means 2000 becomes 200. So the speed you are reducing, of course, the speed and torque is a power of the motor. So when you reduce the speed, and automatically torque will be getting increased. So that is adjusted by the gearbox. Then this motor also getting heated, so that we have a separate coolant for giving a cooling to the motor, and we have power electronics converter to control the motor. So this is what basically a motor and coolant system it is. Now the same vehicle, when you are onboard your battery, it's called floor mounted battery. So it's all like a kind of pouch kind of battery, but we should not say it's pouch, it's a prismatic cell batteries. So if you take any motor, so motor comes with a controller. Okay. So just for this understanding, you look at this. This is the one kind of motor. So this motor, what is the power? It is a peak power. I am mentioning here. 100 kilowatt motor. You see the weight of the motor is 62 kg. So when you compare EV motor, the main intention for the motor to provide the torque, you can look at the torque is 330 Newton meter. So 330 Newton meter, 100 kilowatt motor, it is only 62 kg. Then you assume 1 kilowatt is 600 grams. So this kind of compact motor you need when you design this kind of compact motor. Of course, the other problems are coming in, like what is your peak power and what is your peak torque and what is your constant power and constant torque. As you can see here, this is a typical characterization for peak torque and as well as the constant torque and power profile. Majorly, we can achieve this only when you are designing a proper motor with a proper magnetic saturation limit and as well as thermal saturation limit. That is the one area the researcher can concentrate to bring out the motor. Maybe this is, you can see that how the thermal will be handled. You can see here, these are the cooling tubes normally. You can insert the liquid cooling method, you can handle it. But some other way, using the rotor and magnetic analysis and as well as stator magnetic analysis also, you can actually reduce your capacity of the motor. Now the new age motors are in-wheel motors. We can call it as a hub motor. So what is called in-wheel motor? It means wheel itself, it has a motor and power electronics converter. As you can see in the figure, you can easily understand power electronics and stator, rotor, bearing, braking, everything there in the wheel. Just you take the wheel and connect it with the vehicle. So this is the older technology like mid-drive motor where you have power electronics converter on top of it. Whereas this, motor which is embedded on the wheel, it has everything in a smaller size. So this motor is call it as axial flex motor, and this motor is probably call it as radial flex motor. So radial flex motor size is bigger, but whereas the axial flex motor, its size is smaller. So whatever as of now in electrical controller side or in power electronics packaging side or in motor design side, we can similar practice we can do in this axial flex motor. Definitely, this could be a very promising area. The researcher can working on it. Even you can develop some new kind of technology as well. If you wish to go as an entrepreneur, you can go with this. And these are the advanced systems like multi-motoring system. As you can see, this axle, there are 4 motors are available. So it's a truck type of powertrain. You're supposed to use it. So when the truck is not loaded, you can operate only one motor through which you can actuate. And suppose the truck is heavily loaded, you can actuate 4. Likewise, either you can do it for 2 motor category or 4 motor category. This is all the upcoming technology. And to understand about the better motor, what basically motor it is. It's nothing. Motor is nothing but a battery. It's kind of a stator and rotor connectivity. So the placement of motor, the magnets, particularly PM and some permanent magnet synchronous motor, the placement of magnet and, the design of the rotor with respect to magnet placement will be a matter a lot. As you can see that these are the some simple understanding that how good motor and how better motor it's supposed to be. The better motor you see here, your rotor magnets are bigger. So when you use bigger magnets and ultimately you can go for a better performance in terms of power production and efficiency. But ultimately these magnets are costly. It's neodymium magnets. Magnets are costly. So the windmill situation that you have to improve the motor performance, and provided it should not increase your cost. So you have to adjust your design of the motor, to meet out the requirement for the design. So this one such area the researcher can concentrate. It's a kind of axial flex motor having a 2 stator. So if you use the 2 stator, automatically there will be only 1 rotor. So you can reduce your rotor size and you can reduce your magnet also. There are some articles are available. So one can achieve this, ideology, even you can convert into 2 rotor and 2 stator also. So this is one kind of research you can do. And coming to battery side, so there are multiple batteries like lithium batteries and nickel and so many. I don't want to enter full. But why lithium are accepted? Because the lightweight material and provided it has a very good power density characteristics. So now we have 4 kind of cells are available. One is cylindrical, another one is patch and prismatic and LTO cells. So car companies are looking for either pouch cell, integrated pouch cell, or if they are going for prismatic. Maybe the scooter companies because they're cost cutting and as well, they don't want much cooling methods. So cylindrical cells are prepared. So this is the way normally floor mounted battery, which is nothing but car batteries are doing. So basically cell and module and pack. So it's a kind of pouch cells. They are making 10 pouch or 12 pouch, making as a module. Then the module they are keeping here, and all the module they are connecting series parallel like cells how they are connected. Each and every modules having a own BMS, and each and every battery pack have another master BMS. So it's a slave BMS and master BMS. They are operating and they are understanding about each and every cell characterization during charging and discharging. That's the reason the BMS is taking an important role. So basically, you take a BMS. What is the role of the BMS? Is something like you have to maintain your voltage and current and as well as the temperature. Of course, these are the 3 parameters we have to keep on monitor, and something wrong, you have to cut off or you have to give an instruction to the charger to, isolate the battery, or accordingly the charging characteristics should be changed. Majorly, thermal is a big problem with us, whatever the battery we are using. So we have to address thermal and some kind of discharging distribution. So basically, we have to evaluate state of charge, state of discharge, what is the resistivity of the battery, and what is the capacity, and what is the health of the battery. So one can decide the active and passive BMS. So active BMS, something like everything monitored time to time, and each and every parameters are connected, and accordingly you have to activate your charging and discharging profile. That is called as active BMS. Whereas passive BMS, just like remote control in your TV, just you press it and some channels are changing. No, likewise, just for the measurement of SOC, anything falls, the battery gets cut off. So that is nothing but passive BMS. Now nobody using actually passive BMS. Everybody moving into smart BMS, nothing but active BMS. Then coming to charging infrastructure, as I already mentioned, there are 2 charging infrastructure. One is battery swapping, another one is a direct charging method. In direct charging method, in practice, we have plugged-in charging. So when you constructed the wireless charging, of course, we have a lot of investment, but provided it is a very good solution for the upcoming days. Whereas plugged-in charging, again, it has an investment, but it is affordable one at present status, and it has a lot of requirements like what is the supply you have, what is the type of charger, and what is the type of power transmission converter, what is the communication you are using, whether the grid is okay or not, and what are the supply chain equipments you need, whether it is an Indian made or a foreign made. If it is foreign made, you have to convert in our language and our scenario, and your sockets, and so many things are involving in plugged-in charger. But wireless charger, we don't have much. So basically, to understand about charger, there are 2 chargers. One is onboard charger, another one is offboard charger, and another way AC charger or DC charger. So onboard charger in sense that end of the day, battery will charge by DC. So onboard charger should have a DC to DC converter, means AC to DC converter. It's nothing but a kind of rectifier circuit inside the car. That's the reason it called as onboard charger. Suppose there is no availability of onboard charger, you have an option to directly connect it to your DC supply to the battery. So it is a offboard charger. So you can call it as DC charger, is an offboard charger. AC charger is an onboard charger. It's very easy to understand. There are their own advantages and disadvantages. Of course, when you go onboard charger, you have to bear a little bit extra cost to your car because you have an onboard charger within your vehicle. When you go offboard charger, your costs get cutting off because of you are not using a charger. But however, the DC charging availability, so bigger charger is needed, and maybe solar charging and this facility ought to be arranged. Then some kind of understanding is also there about people are telling half an hour charging, 1 hour charging, and something like that. See, charger is nothing but a power electronics. So when you feed more current, you can charge it more. But your battery able to get that current or not, that's a question mark. Say, for example, I am bringing maybe some company scooter. In my lab, I can produce 200 amps current. But 200 amps, if you connect my scooter, no, the scooter started to get burned. It means battery get burned because the reason the battery, what energy it can afford, that energy only can afford. So to address those things, there are connectors are there. So universally it is called as SAE standard connectors, which will be called as CCN1 charger, CCN2 charger, and even Tesla have their own charger, and Japanese people are using the charger called Jedamo. So it's all about the plug point actually. Your mobile phone, what you're using now, it's type 1, type 2 like that. That is kind of chargers. And there are a lot of standards are available. So normally called a J standard, it is about charger and some kind of radiation standard and kind of IEEE standard. And this is a swapping method. Maybe scooter, it's so easy. The pictures, giving inference that how difficult when you go for a car and bus. When it is go for a scooter, it's very simple because it's very handy, but the car and this one is not good actually. So then public charging station, and it was the picture, it's a blended drawing in India. But now you see this is the same India, Ola charging in Delhi and Tata Power in the street, and HP charging station that created in India. This is what Japan, now they are practicing. But very soon in India also you'll be get the same infrastructure. It is something like a metro buses are coming here and stopping, maybe 1 kilometer, the buses are stopping at 3 kilometer one, the buses stop stopping. During the time that there could be a flash charging, pass to the vehicle and it's getting charged. So this could be another good idea, but as of now, very few countries are attempting because again, the civil and grid infrastructure is needed for this. And this is the future actually. Every vehicle is going to be generate power from the charger. Every vehicle going to accumulate power from the solar, and whatever the energy stored in the battery that is given to the grid whenever the availability is needed. Say for example, daytime you can charge your battery through the solar or wind. Nighttime there is no wind and no solar, I assume. During the time you can send power to the grid. So the study is saying in Europe, it is 100 EVs in a XUV vehicle, they can produce nearly 1 megawatt power to the grid. So it is nothing but vehicle to grid. In India also, there are a lot of initiation has been taken, but not in the megawatt level, at least in bidirectional. So this is what a new concept called wireless charging. As you can see the right side, there is a road called Green Road. And that is what I have shown in my lab picture. We are also created the same, the Green Road. So maybe we can create as a blue road actually, but it is a real road. So it's a green road. So they are creating a charging infrastructure on the road. So this is autonomous vehicle. It is the future. Everyone knows about it. When the autonomous vehicle comes, there is no choice. We should have a green road, which means wireless charging. The reason is there is no driver, then who will be charged the vehicle? Correct. So someone has to be charged the vehicle. End of the day, you have to take a wire and you have to plug in wire the charging. Then only get charged. So the wireless charger, it's mandate for an autonomous vehicle. So yeah, so the vehicle itself is understanding when it gets hungry, it's go to the charging pad and get charged. So now I'm going to showcase that some of the slide, how we are scaling into wireless charging. So basically wireless charging, as I already mentioned that, quickly I'll go to the wireless charging. Okay. So it's a static and dynamic. There are two ways of wireless charging. Okay. So one is static. It's very simple understanding. You just park your car on top of the charger. It's nothing but a magnetic pad. It's not a magnetic pad. It's an electrical pad, but basically the flux is passing through and through that we are getting charged, so end of the day, it's electrical, but actually flux is only traveling between these two. So as you can see the figure, what happening basically, your phone getting charged now, right? The same principle, like, so we have a coil in the roadside and we have a coil in the car side. So you give a power to the roadside coil. So, it is getting induced magnetic field, and the magnetic field pass through and the car coil getting connected. So automatically this flux is transferred there and it's getting charged. So that it's AC supply, then you get converted into DC and then getting charged. So it's very easy to understand, but realistically, to making it is very tough. And more importantly, when you go into dynamic charging while moving the vehicle, of course, while you are standing your vehicle, the flux will be easily passed through. But when you are moving your car, according to our Faraday's law, dP by dt, where the time is respect to the speed of the vehicle. When the speed is high, automatically the dP by dt will be, you will be get a lesser value. So, so that automatically the flux transfer will be lesser, so the charging will be lesser. The challenging is when you are roading, moving the vehicle on the road, during the time, if you charge your vehicle, particularly with the good current value, maybe you can call it as at least a constant charging itself is very, very, very difficult. And another thing that when you connect to the grid, grid also get penetrated. Again, the same story, like when you go into road, then some of them getting charged and some of them not getting charged. So you have to always see the input side, correct? So grid also get be matured and according to handle. And future saying that one vehicle could charge another vehicle while it's driving, it's a conceptual idea, but probably it may happen in another 10, 20 years or 10 years later. So it's saying that it's a bigger vehicle, maybe have a large battery, and they maybe have a wireless charger, and that could be connected to the next vehicle. It is maybe small. In a year, it can make it charged. So during the travel, you can get your charging. But practically, this is possible. It is a model created, but basically it is highway, then there is a solar panel. The power will be given to the electrified road, which is nothing but a wireless charging road. So whatever the power generated, that will be given to the road, and automatically the vehicle get charged. So you can showcase the net zero road. So this is ideal picture in the Europe. So what they are telling about, there is a hydro plant, there is a solar plant, and there is a WPT charging station. So in a small area, when the vehicle is crossing, during that time the vehicle gets charged. That's the idea. So what is it, wireless charging? It is not a new technology. It's a very old technology. Our grandfather Tesla is actually, experimented. After that, the professor from MIT, US, Boston, they create a company called BSACIST, taking the same input from the Nikola Tesla. So they are proven in different way, like power will be captured in a short range, medium range, and longer range. The efficiency of electricity, initially it was 40%, close to, but laterally there are many scientists, came up and created so many technology. Actually, the pure technologies comes from Qualcomm company. May know about this Qualcomm. Sometime it was with our Nokia Sri Perumbudur. So then Delphi and then Korean Soft Technology, those people really they attempted for a car to charge in 2012. But you see, this technology actually not created by Tesla. According to me, this technology is created by Faraday. So then the Tesla taken it and he has re-experiment and showing that its power will be transferred because the flux is transferred. But now Tesla company is using wireless charger, and there are many people in Japan. You can see this public charging. They are having a demonstrated wireless charging is possible for the buses or not. And there are other way wireless charging using beyond the wireless charging vehicle. It's a drone charging in, medical equipments, ear parts, and so many things in automation and everything. But this is what one technology readily available. You can even buy in Amazon. And this is you can buy in the pacemaker, right? Pacemaker, heart patient, they also can charge their pacemaker through wirelessly. This is also there. You can see that close to 70 lakhs operation has been done for the last 10 years. And they are using wireless charger for charging their pacemaker. So basic understanding for any wireless charging is XYZ graph. It's like there are two coils, I said no. The receiver coil is there in the vehicle side. So that size of the vehicle side coil, and what is the power value? It's called power budget. And what is the range? Which means what is the distance between car and as well as your road. So maybe my car and road, maybe 1 meter, you cannot get any charging. Suppose I'm getting 10 centimeter, I will get charged in a better way. Maybe 20, yes, I can get charged. And provided the coil size also very important, where we are looking for a fast charging or, kind of full floor charging is not possible because vehicle has many components. So the size also will be limited in your vehicle because your floor area will be limited. So accordingly, you can plan. And of course, the budget of the power, you cannot straight away take an equation from wire charger. Maybe a wireless charger, you maybe compromise half of the power. The reason is that, as I already mentioned, that it is about how much of size of the coil you are on board into your vehicle. So that is also matter a lot. So here you can see this is a typical picture, the wireless charging. First AC supply, and you have power factor converter. Then you have to give high frequency converter. The reason why high frequency converter is operating minimum value 85 kilohertz. That's a standard 85 kilohertz. It's a SAE standard. Why? Because less than 85 kilohertz, there are some other frequencies are created and allocated for walkie-talkie and some telephonic and communication system. And 85 to 200 is a range is given for wireless charger. So resonance circuit principle, any high frequency, you have to match up with a compensator LNC component so that resonant principle XL is equal to XC. So you'll be get a maximum power transfer. That's a AC maximum power transfer principle. So through that you can, but of course you can use some capacitor and inductor with the coil. It is called as compensator circuit to match up the XL and XC value. So once you are arriving the energy, which means flux into the secondary coil, and that is a AC supply anyway with the high frequency that you have to convert by using high frequency rectifier, then you can charge your battery. So this is what normally we can do. The question is how efficiency wireless charger. Of course, the efficiency not like wire charger, but definitely you can reach out to nearly 90% efficiency. Particularly the losses are happening only through the transmission area between the transmission and primary, which is normally called misalignment. So the misalignment sense, if you are exactly parking on top of the coil, it's fine. Suppose slightly you are misaligned, then definitely you are compromising a lot of the efficiency. So why that efficiency? The principle is very simple. This is transmitter coil. You assume it is connected here. We can take a pencil. Yeah. So this is a transmitter coil. It is nothing but this. This is a receiver coil. It is nothing but this. So you see the flux is passed through here. That is what the flux I drawn here to pass through in the red color. Suppose if both are properly aligned, it's meaning that the transmitter coil properly, all the flux is going to receiver coil, which means like red color dotted lines. But unfortunately, you are moving some way away, then some of the flux go away. So basically, this is called it as leakage flux. The leakage flux creating unwanted heats in other part of the car. So, and of course, that is we are compromising glasses as well. So this is one of the major concern we are to taking care in the charging. So another thing that the distance between the coil is a matter a lot, because the distance is indirectly related to your magnetic flux density and as well as the area of the coil. So the next, oh my God, this is a problem. I get wrap up every time. Okay, so wireless charger and wire charger is not a, which means transformer and wireless charger, it's not a big deal actually. You can look at this figure, you can easily understand. See, transformer, we have a core here, but the core important is that to transfer the flux around in a proper portion. Basically, transformer have 95% and more. The reason is that you are providing a core because the primary flux, whatever created, that is passed through the secondary through the core. But in wireless charger, there is no core. Electrically or mechanically, it is not connected. You are connecting through flux wave only. So you should have a compensator to do that. Actually, you see here two capacitors connected here with this coil. So this is nothing but a compensator. Probably this compensator help you to make this mutual inductance between these two coils, because the principle of the transformer is primary and secondary, you have to get a proper mutual inductance. Similar way, the wireless charger also primary and secondary, you have to get a proper mutual inductance. To achieve this mutual inductance, the resistance value, the individual inductance value, all to be properly calculated. Even then you are not getting mutual inductance, then you have to add some capacitor and inductor for a compensator circuit. You can, through that you can achieve your mutual inductance. Basically, this is what transformer and wireless power transfer. So of course, the leakage flux for the transformer, nothing is less than 2%, because you have a core on the transformer. Whereas wireless charger, we don't have any core. So there will be a large opportunity for the leakage. Close to more than 80% leakage is possible actually. And frequency for the transformer is 50 Hz you are normally operating, whereas your wireless charging, you are operating into kilohertz level. So these are the other aspects to be. So wire and wireless charger, a single line diagram for making the charger as a black diagram way you can understand. The wire charging and wireless charging is nothing, uh, uh, totally maybe it's not different. It's maybe a same. You can see the output side. Here transformer is there. Here we have a coil. After the transformer, we are straight away connected to the rectifier because the transformer basically convert without changing any frequency and just changing the only power. Whereas wireless charger, there may be a change in frequency as well. And so you have to be actually conditioning your power using a power conditioning circuit. That is the only challenge. And probably you have to use a control board to communicate to the input side because, the wire charging, everything controlled the input side, but wireless charging, input side, power factor controller and high frequency controller you have to do, and provided the output side battery charging also you have to be concentrate. So maybe you have to communicate through wirelessly by using any wireless communication like Bluetooth or any Zigbee or any Wi-Fi and any other communication. You should be communicate through wirelessly, and you have to be connect the charger control board from the input side and as well as the output side. So there are two kind of charger. One is inductive charger. We call it as a IPT. Another one is a capacitive charger, is a CPT. So IPT is actually mainly used. The reason is that it is an inductive charging. We can own the wiring and lesser space is sufficient for making a good power transfer. Whereas capacitor, it's also very good, but you need a large space for keeping a capacitor and do that. And there are a lot of other issues also there, but circuit wise is both are same. As I already mentioned that the two coils are there. Likewise, you should have a two capacitor plate between the primary and secondary. But beyond that, there are some issue will be there. So you can see here, even the misalignment also, your capacitor is getting very less misalignment, whereas the inductive you are getting large misalignment. So here I am showcasing that inductive charger, for example, properly aligned. You see the blue color, all the flux are positive flux is properly handled. Suppose the small misalignment will be happen. There are leakage flux, there are negative flux. Both will be affect the coil and get heated. Of course, it will be loss of energy only. Whereas you can see the capacitor, any movement you can actually get it only the positive flux. But the reason you should have a large space of capacitor plates. And of course, you have to operate in megahertz level. So megahertz means you have to go for a GaN-based device. The GaN-based device again so costly. So those are the reasons actually, CPT is not used, but simple comparison. IPT means inductive base is magnetic principle and capacitor is electric principle, and its material used leads and is copper, and cost is very high. Actually, this cost is less and size is small and size should be large. So this is the only problem in this CPT, why we are not using for this wireless charging. So rest of things are nominal. And as I already mentioned, static and dynamic. So we have discussed already about static is so easy because everything is proper and you can easily transfer the power because you can easily park. But whereas you are driving, there are multiple cars are coming. So when maybe you go slow and you maybe go fast, and you can easily get misaligned because you cannot drive exactly and your speed is also there. Your vehicle maybe go high speed, then automatically other issues will start to come. It's called ring effect issues, and multiple vehicle getting charged, and you have to be properly penetrate your power. Power flow should be managed. So all these things are available in the dynamic. So designing the coil, designing the charger for this wireless, and there are 5 schemes is very important. 5 subsystems you have to develop. One is electromagnetic coil design, another one is compensator, and then power transfer converter with the control systems. And you have to always see the battery side energy condition, because when you are charging wirelessly, if you are perfectly charging with alignment is fine. But if you are having a misalignment, then the battery management getting confused because you may go to the discrete kind of charging. So a proper battery management system for wireless charging to be designed with the health management circuit. And you also supposed to have a communication to be communicated properly between the charging pads and primary and secondary. So these are the charging pad arrangement. Basically, if you open any charging pad, what is inside? There are coils. It might be a copper coil, but normally it's a sleeved copper coil. It is called Litz coil. Then we have a ferrite core. This ferrite will be used to use more magnetic field, and we have a aluminum shielding around it to protect it. Why we are using aluminum? Because you assume that the flux will be go anywhere. Not only coil, right? So aluminum is a material to arrest the flux. So only flux will go only to the coil and you can tap it that output. Whereas the rest of the vehicle body, it won't flow it. So that's the reason we are using for aluminum. And these are the compensator circuit. It's a combination of capacitor and inductor only. So how the capacitor are connected, and likely you can call it a series. Here you can connect capacitor series and other side is parallel. So series parallel, and these two capacitors connect in parallel or parallel, and this series parallel. So this series parallel, everything is going to bring K. You hope you able to recollect. The K is the thing, but a coefficient of coupling for the transformer. And of course, when you read the transformer and design the transformer, there is a quality factor. So these two components actually, decided by the compensator. The compensator help you to go for it. So I'm just going to skip so many slides, so don't want to take a lot of time. Probably I can take it a very important equation through that you can understand. So look at this equation. This is a final equation to understand about wireless charger. So the efficiency matter a lot. And this efficiency also involves so many parameters. So simply you take a parameter called L. It's a coil parameter. So because there are two coils, right? This is a coil number 1, coil number 2. This is a transmitter coil. This is a receiver coil. So this is also L. It is called L1. This is called L2. So each L1 and L2 both are having a quality factor, because the formula of quality factor, something like directly proportional to L1. Correct. Some equation will be there. So both coil have a quality factor. So the quality factor, and these two coil, you have a coefficient of coupling divided by root of L1 L2. Some equations will be there, no coefficient of coupling. For the transformer, you should use the same equation, coefficient of coupling. So K and as well as the Q value will be important to design any wireless charger. Say for example, you assume there is one stationary wireless charging coil. The coefficient of coupling is 2. It's nothing but K is 2. Okay. Then the quality factor is 300. Assume for both. So you see where it is available. You see this is a quality factor. This is efficiency. You see around 300 means here. There is coupling factor 0.2, right? So you can see this daughter point is about here. So you see nearly 85% close, the quality factor 300 and coupling factor 0.2. When the coupling factor getting increased, suppose I'm using coupling factor is the same quality factor 300, is 0.3 is around here, because the blue color is 0.3. You see then it's close to 96%. So when the coupling factor getting increased, automatically your efficiency getting increased. So the design, you have to ensure your coupling factor, and as well your design, you ensure your quality factor, because you see the quality factor also getting increased, your efficiency getting increased. But nevertheless, your quality factor getting increased, automatically the size of the coil getting increased because L value getting increased. Okay, so yeah, so this is what the understanding between the quality factor and as well as the coefficient of coupling. So we have to properly design. There are so many equations. Okay, we have a review paper. I will tell you in the end. You can go through the review paper. Actually, you can able to easily design your coil. The radiation, everything is there. So you see, actually, wireless charger we started about 5 years before, even not 5 years before, 2017. It's close to 7 years. I just started the first exercise to create a unmatured coil design. As you can see, there's many examples in front of you about for 1 kilowatt charger, and we are slowly developing. And now we are creating on startup also. So this is our current pictures. We have developed so many chargers for so many applications. As you can see, the right side, all simulation we do first in ANSYS. Once it is done, we understand that all the optimization is done. Then we'll go for a hardware implementations. For that, we will go for a coil design in the naked model. So once you've done the naked model, we have a Ferrite arrangement. I will do that. So maybe for understanding and just showcasing how we are doing it. So just for assumption that we are taking 1 kilowatt charging for a circular means, let's go with what is your frequency, what is your voltage, and what is the power, and how many quality factor, and what is coupling factor, and all to be calculated by using different formulas. Then you will find out what is your primary compensator and secondary compensator. Then you will go for a sketching model. Once its sketching model is done, the same sketching model we are planning to go for ANSYS. So through the ANSYS, finally, you can see this flower drawing. The flower drawing showcasing you that I am creating a figure of flowers, something with a flux movement. Going to the primary to the secondary is in a flower shape, which means that it is properly created and properly going and hitting in the second coil. The assurance, when we are getting it, then we can go and fabricate with the same value what we are already planned. So then we'll go for the hardware setup. So we are also created so many coils. This is all example of what are the coils we decided. And the hardware setup, maybe you can see the right side, we have separate hardware setup, then we whatever the coil we designed, then we tested it. Once it is tested, the real vehicle we uploaded. So you can see that real vehicle, we have already demonstrated, the ether, how the wireless charging is maybe used for the ether. And definitely, this is what currently, just maybe my first slide, second slide, what I have shown, that is what the civil construction itself, we create a lab structure, and there is a principle called wireless charging tile. It has been patented, and now we are going to commercialize with one tile company. So this is our experimental setup. We have multiple experimental setup. As you can see, we are testing with the real battery. There are people are using with the resistive load, but we are not using that kind of research, and we are straight away connecting into the battery, and we're trying to charge and meet out the battery profile with respect to the wire charging. And we also exercising this directly conduct from the grid and as well as conduct from the solar. So to both study, we have done it, and we are able to accumulate so many research results, and through which now we are creating a platform for any size, any application, any current rating, any voltage rating, any power supply inputs, either it's no matter it's solar or it might be a grid supply, we created. And also we created some new type of coil. It's all saved different ferrite, and probably a markedly available ferrite based coil and our ferrite based coil, we are reducing 20% of the cost. And these are the different placement and how the ferrite can be matched it. And so apart from that, whatever the technology we are put in, and we created our own vehicle. For example, we already created one company in the motor side, and now we are developing another controller for this motor and the charger, and all together we are creating this vehicle. This is a purely wireless based charger, in-house to motor and controller. And these are the key area what we are working in our lab. As I already mentioned, that electrical motor, controller, plugged-in vehicle, energy storage, fuel cell, and autonomous vehicle, and digital twin, some materials preparation for thermal management and power electronics converters. So this is our charging track. It is in a construction stage, so how we are tested, after all testing is done, then only I allow the engineers to go for FRP flooring. So we are also doing vehicle-to-vehicle charger, and these are published in different IEEE papers. And this is a drone charger for BIPV. And so this is another new idea we have created. Within one charger, you can create a 2 battery charging method, which means one is charge one battery and another is charge another battery. It is called it as 2 winding in one coil, and we created our own GAN-based power electronics converter. And we are also tested with the cycle, and we have a cycle in our lab. You can see that how the cycle is charging, and probably that we are installed in very soon in SRM campus. And now already we have started for charging the same infrastructure for electric boat. So we're getting some inputs from Mauritius, one electric boat company. This is a company. From that, we are actually collecting the data, water turbulent, and through robotics, we are programming it, and we are now started that research. And also we are done with some research, the wireless tile-based system. No matter what vehicle it is, any vehicle, it can be charged according to your profile. And these are some of the converter what we developed. Maybe some slide is repeating. So you are able to understand that how our students are working. This is one of the new idea like that. The wireless charging tire, we principally it is very difficult to come to market, but it's ideation stage. Like the wireless charging tire we made, and we are making a proof of concept. The tire, it can charge directly. This is our cycle, and this is our benchmarking for dynamic charging. And this is another static charging test bed. And this is the wired charging. So wired charging, wireless charging, testing protocol is same. We are already captured some kind of testing protocol. Currently, we are doing a power quality study with the grid. And this is the thermal side what we have worked on. We created a honeycomb thermal, and this is a GAN-based circuit what we developed. we attach this. So these are our first generation circuit. Probably we are working with some nano composite material through which we are planning to go for another thing. So we are also doing many other research. You can see that we are consulting Ashok Leyland Switch Mobility for creating a axle, and these are the multi-motoring system we are developing for one auto company. And this is what that picture, previously what I have shown. And yeah, so this is a algorithm we are developing, that multi-motoring by using SRM motor. These are published in IEEE transactions, and this paper also about to publish, and it's got accepted in another paper. So we are also working with the axle flex motor. Presently, this working or going on. You are able to create a new motor like axle flex, and probably that will be we will create another company. So already one company we are supported. They are reaching into market level now. We are creating another company. Also, we are studying about different solar simulator. In our building top, we are creating some solar structure, and through which we are achieving some kind of results, and how the chargers can be used for the solar. And my postdoctorals are working in this area. And this is our fuel cell. We have two fuel cell system. One is the lab side. So we are creating our own power electronics interfacing, and through which we are controlling over any type of motor. And as well, this can be connected to the grid. And we have created a fuel cell vehicle. This is the first fuel cell vehicle created in India. Innovatively developed our fuel cell track. Maybe it is not full matured, but we are able to drive the vehicle. Now we are working on how this vehicle can be excel with different energy management. So these are the energy management curve, and we are creating a front end our own fuel cell. Actually, we are selling this actually to the other colleges as well. Now we created a full kind of system and for the study purpose. And these are the coolant system. Probably many are here in electrical, but we are creating some coolant system for the battery and thermal package. And these are the results. And after our coolant system, as you were able to see that there are temperature boundaries started from 43. We are able to bring into 21 degrees centigrade. So with that, we are creating so many batteries. We are giving these batteries to the school students and college SCA competition. Even one of the Crescent students also got battery from our lab only for their vehicle. So we are actually not selling the battery. We are giving the students, the battery that's coming with the cell, and we are packing the battery and give it to them. And these are other facility what we have. We have Hill emulator to test any kind of work. These are some consultancy, and then this is our battery pack testing facility. Yeah. So this is our autonomous vehicle. Of course, autonomous is one our criteria to take our vehicle into our campus. We are building an autonomous vehicle platform for making our SRM campus operating by autonomous vehicle. So the pictures or whatever you are seeing, we are changing the buggy in autonomous. We are already have some pilot study. So still it's not published, so we cannot showcase more many data, but slightly you can able to understand that the map. You can able to understand the video. He is creating a lab map, and you can be able to see the simulation. So what it's not a simulation, it's a real-time value. We are capturing the other side, the vehicle is moving. You can see that vehicle is moving. You're able to see that blue color is created and small components are moving. No, it's a real autonomous vehicle. When the vehicle is moving, you're capturing in other locations into the digital twin. So now we are making this vehicle, and probably very soon we will be located. And the same vehicle we are taking to the road. Actually, we are not moving the vehicle. We are just parking and capturing all the images. So as you can see that, it's easily capturing, identifying who is woman, who is not moving, who is moving with what velocity, and all this thing we are capturing. And yeah, so this is what, and yeah, this is a vehicle, and probably we are taking a benchmark from Taiwan National University of universities, and we are collaborating with some other professors, and we are doing it. And this is a ROS-based system we developed. Again, it's a small autonomous vehicle we have. Basically, this is a master brain. So this is capturing the images from everywhere, and through which we are doing it. Yeah, so this is a real vehicle. You can see that nobody is driving the vehicle. It's actually vehicle is moving on. So the guy who is sitting in the side, and I'm challenging my car, is parking there. The students are not hitting my car. So here the map is also here. You can see the map while vehicle is moving. All are captured. You can able to see that vehicle is moving, and all are captured and momentary. So we are taking pilot study. SRB is a huge campus. The daytime is not possible. During nighttime we are doing it, but probably within 6 months we are able to take a pilot study. This autonomous vehicle to running at SRB's campus. So ideally this entire vehicle is prepared by us. It is not procured by anybody. Every motor, and you can see this structure everybody created in our lab, and some composite material we used it, and chassis also prepared by us. It is hitting any wall and spring sparing and everything that by this chassis, and from there it's going down, and finally this is our vehicle, how it's created. And so this again fuels also we created our own vehicle right from the scratch. So this is our current setup of the abilities, and there are so many, conventional we have created and showcase so many stakeholders. So this one actually, I just wanted to show the slide view, and that means bird view, that how the lab is always, combined with the components, and so these are the equipments. It's all available for a scholar who are master students. But only thing, they're publishing papers to cite us. And for a company, we are actually giving a cost based, and everything is government iSTEM portal is stored. For information, in India, except IIT, we are the only one who stored 71 research facility in iSTEM portal. 2,800 people as of now, they got benefited through this iSTEM portal. And we also conducted so many events, for the school student, we have donated the kits and all developed by us. And of course, so many programs we are connected with so many IITians and so many things. And we do conducted a hackathon for a 48-hour hackathon. Last year we conducted, it's got very famous. We also collaborated with the different funding agencies, and we also donated our vehicle to DST. As you can see, this is our HRD minister, is our education minister. I demonstrated a technology of wireless charge in IIT Hyderabad. Yeah, see, this is some of the showcase from the different people who are coming and visited in our lab. And yeah, so this is our startup. What we created is about 220 crores company we created. We are very happy that we are going to create another few more company in upcoming years. So yeah, so this is what my presentation, and of course this is what our development as of now in our Center of Electric Mobility, what we are doing it. I am purely acknowledging my research scholar and students, and our SRM management, our funding agencies to support us and to creating this much of effort. Getting realized now the Center of Electric Mobility in SRM, almost every part of India, including ISC, IIT, NIIT, they know about what we created as infrastructure for the next generation engineers, as well the next era of research, what Indian community has to be supposed to do. Yeah, so this is my presentation. Now we can have a discussion with us. And I forgot to say that we have also started a new course called BTech Electrical Vehicle Technology with the ARI. It is a very limited seat, 30 seat, and probably we are open for this year admission. If anybody interested, you can come and visit our facility first, then you can see your curriculum. So I am 100% guarantee that those who are offering the course here, definitely they will get a very big company. For my PhD students are getting salary about 20 L for a year. So I graduated 2 PhD scholar as of now. I am not graduated so many PhD. So one is working in Singapore Institute of Technology, and another working is the Eiler Motor Chief Engineer for the powertrain. So there are people are in BTech level. We got placed in about 15 lakhs and 18 lakhs, and few of the people are worked for a full-time startup, maybe another 1 year. So hopefully we will get some more new startup for the upcoming days. Yeah. So this is my presentation.
Thank you so much, sir. Thanks for the comprehensive and insightful session. Dear participants, this is Godwin, your co-host for the session. I'm taking you into the question-answer discussion. I request all the participants to keep their questions concise and focused on the session topic. Please go ahead with your questions.
They can open the mic and directly talk, right?
Sir?
Yes, sir.
They can open the mic.
Yeah. Yes, sir. Now permission given.
Yeah.
Sir, good evening, sir. First of all, very nice and clear presentation, sir. Sir, I have only one query. If you want to teach EV course for the UG students, please guide us about the minimum and mandatory laboratory facilities, maybe in terms of mechanical as well as the electrical engineering point of view.
Sure, sir. Actually, I'm very much grateful to hear you from you because the FTTP program is mainly for not for the research. It's for faculty to develop the updated, and we have to give it back to the students actually. So
Yes, sir. Of course.
yeah. So actually, we have taken one initiative, sir. We are planning to host by February. Maybe I will pass through to the Crescent FTTP people. Maybe they will circulate the brochure to all of you. The idea is that very simple. We are going to conduct a workshop how to create an electrical vehicle bucket, which means specialization of electrical vehicle for a BTech electrical vehicle program. Okay, because I hope everybody, even Ananisti, they're offered this, right? So in that, what are the courses you may have? It's a joint course, basically. For example, electrical vehicle architecture. What are the open source softwares are available, and some of the availability with us, how it can be served to others through remotely. Point number one. And what way Saturday or any summer or winter holidays will be identified to taken up for the internship based course. Like they may come here 15 days, they work in a specific technology, for example, with the instrument, and they can hire credits so that they can take that credits and they can earn. But coming to straight away your question, suppose you wanted to focus on to create a small lab. Yeah, so we have some model, and probably we will during the workshop we maybe explain that. But the simple idea is that we are going to create a miniature model for everything. Say for example, to create a EV lab, something like battery side, the battery characterization the student wanted to understand, but the battery characterization cell cycler is so costly. So make it possible to bring it into maybe 3 to 4 lakhs range. We could learn many things actually. Secondly, this motor dyno, what I have is totally for the industrial grading, but it's the same mimic, we can make it for 1 kilowatt range, through which we can make like a motor dyno setup. You maybe connect any motor into it, and maybe with one FPGA controller or any one hill controller, through which they can change the program and they can validate something. Maybe this could be a possible solution. I am working with one company, it's an Indian company only. So maybe during the workshop we will demonstrate that. So through which you can conduct your research also. Maybe you can add some ModRap or any kind of programs. You can add some more, etc. So actually this too itself, probably students to understand practically many things. Maybe they have to come to our center, like they have to spend some time. It is an additional credit for them to scale. Of course, I do understand that the tier 2 colleges, they cannot spend huge money like us, but ultimately we faculty, we have to write a funded project, we have to set up some lab. That's only option. Maybe you can write a research project also. Slowly you can procure some components, So even I grown in that way only. I bought like 3 lakhs is my first funding. Then now I come up with the 15 lakhs, 15 crores, a single project. So every project I created a small infrastructure, and of course, small things of investment, and yeah. So in that way only it is possible. But with the course level, there are open sources are available. So we are going to teach that, and also some of our facility will be take it and conduct it remotely. Say assume that you can access our access our instrument through your lab, but through the digital team, which means that through the camera you can see all the available system, and some front end will be there through which you can program, and that will be take some latency. Probably that program we will validate it first in our side, then we'll click one click, then automatically it will be get into the emulator. So something we are working out. Let's see in February, we maybe focus on showcase, and then we can plan further about it. So beyond that, I am always open. I'm guiding many colleges. The bucket level, EV curriculum will be developed. What way they may be afford to get a good job in automotive industry. In that way, we are supporting actually. So anytime you can maybe chat, or you maybe get my WhatsApp number from. So please share my WhatsApp number to everyone. Okay, the same number for my mobile. Don't call me. Just please WhatsApp. Then when I have free, I'll call and talk. So we can personally discuss, or even you can visit anytime our center. Just sending email and put on WhatsApp. So we will tell probably every Saturday and Friday. So you can come and visit anytime. Yeah.
Thank you, sir.
So maybe
Participants, any other questions? Even you can type it in the chat box. I'll take it forward.
yeah, you can type or you can open, you can talk.
Sir, I have a question on the fuel cell part. Are you involving model-based development, RCP and Hill for that as well?
Okay. You're asking me. Okay. So we have three setup actually, fuel cell. One is that the actual fuel cell model. Another one that, bidirectional power supply, we have a emulator type. But the emulator type, like, temperature is, you cannot blame on it. But rest of the parameter, you can actually emulate it. It's like a PHL. It's not PHL, it's an emulator. Directly, for example, cell characterization, how do you do? For example, nominal voltage, threshold voltage, and some boundary you are fixing it, right?
Yes.
Likewise, you can fix the boundary. The power supply will give the actual power what you need from fuel cell. Say, for example, 72 volts, 120 amps you need. For that, you maybe configure your availability of MATLAB data, and you can put it in the emulator. It will be work. Correct.
Yeah.
This is the one system I have, but temperature dependency will not be work. Whereas in Hill emulator, how it is, my Hill also take a temperature, which means your MATLAB model directly work as a low signal model. And finally, that low signal model gives you voltage and current. Like a typical, but temperature is another parameter. Through the data logger, you have to take a temperature, but it's not a real temperature, but it's an estimated temperature. So what normally we do that, we do in the Hill, and then finally the same scenario in the real time we operated. Ultimately, when you are operating real time, again, the temperature variations, we are also getting about 7 to 10 degree temperature because it is about the membrane thermal behavior. So this much level we are working, but we are mainly concentrating on power electronic side and output power optimization side for controlling the hydrogen flow in input side and controlling the current and voltage in the output side. But we are also not practicing anything in the membrane side actually. So because we are not basically mechanical or chemistry background, no, so we are still able to get some good collaborator to work on that area as well. But anyway, with that temperature level, we are still not good actually.
Sir, one more question. So you told about the real-time testing. So when you test the fuel cell in the vehicle, you must be logging the data, right? So
yes.
How it's happening? So what kind of hardware do you use?
Logging means we have a data logger. You can log everything as a low voltage signal.
Okay.
But as a fuel cell vehicle, what we did it, that the entire power line, for example, output power line and as well as the input power line. Input power line, all the hydrogen flow, air flow, everything is captured to the data logger. And likely output side, voltage and current, everything captured by the real-time power analyzer. That is also inclusive of data logger. So we are given through the lab view. So through which we are plotting the graphs. So for example, PV emulator graph is coming now, like that we are plotting the flat.
Okay.
So so that kind of a whole system we developed.
So you are using NI systems for that?
NI system for only the front panel, not for the controlling. Controlling we are using this Raspberry Pi. Again, power electronics converter, we are using Raspberry Pi, whereas the input hydrogen flow side, we are using some flow controller.
Thank you.
Sir, good evening, sir.
Yes.
Sir, I'm Dr. Rahman, sir. I think
Yes,
I'm your student, sir.
Oh, which batch it is? Chandrababu. Oh, Chandrababu. Oh, how are you, Chandrababu? Oh,
Yeah,
very
fine,
good,
sir.
very good.
Fine, Sir, your presentation is very excellent, sir. And you were given a lot of scope about the EV vehicles and also how you are going to develop.
Yes.
So here my question is there any role of AI or deep learning or machine learning in the electric vehicles, sir?
Definitely. Every part it's having, every portion, wherever I am discussing, every portion, AI, ML involvement will be there. Maybe, for example, motor side, nobody thought of AI, ML role. So what is the role of the motor side AI, ML? For example, we are talking about ADAS system, right? So the ADAS system behavioral will be mapped that mapping is actually given to the motor controller. For example, in motor controller, we call it as adaptive controller. What is called adaptive controller? When you press the throttle, according to the requirement of your speed requirement, and of course the road condition, and of course the vehicle weighting capacity, you are creating some adaptive model. For that adaptive model, your motor controller to be activated. Correct.
Yes.
So here, the AAML, everything involving. Actually, we are doing that kind of work also. But I thought of taking that this take long time. So I'm cutting up those things. So likewise, charger also we are doing. So every part we are doing, particularly autonomous vehicle, everything is AAML. So it's always a good idea to use AAML, but not a passionate to do AAML because of AAML supposed to be used something. But really there is a requirement for using AAML, even for a limited level also, it is actually good. Because role of AAML, it is only mainly in our side is optimization for getting the better results, right? So of course, and more importantly, to collect the proper data. That is also we can use the AAML. Because there are a lot of data will come. It's called as raw data, but only few data only help you, correct? So for gathering those data also, you're supposed to use that, not AAML, machine learning is supposed to learn, and the machine will be understand that what data only it's needed, and substantially that data only enter into controller. So that is very important actually.
Sir, thank you, sir. Thank you very much, sir.
Yeah. So if no more question, because I have to leave to home.
Yeah,
so
sir, one more question.
Sir, one more question, sir.
Yes, go ahead.
Sir, good evening, sir. Myself, Malini, sir. Sir, actually, in your EV, have you used that PMB or DC or a switched electrons motor? Because one of your slides shows that and you're using like SRM also.
Yes, ma'am.
There is an issue with ripples.
Yeah. Please go ahead. Ripples?
Yeah, ripples is what a maximum issue, right?
Yes.
That efficiency is reducing.
Yes.
And how you're preferring that SRM, sir?
Okay, fine. So, for example, we are working PMS motor because PMS motor is a market. We are working PMS motor because we are working axial flex motor. SRM motor cannot be converted as axial flex motor. So the intention for working in this our lab axial flex motor, not to publish any paper, do research and all. It has to be created in another company. Some of the students are working. And coming to SRM, of course, your right question is right question that the ripple in the SRM is be high. So we are working in 3 areas, particularly ripple mitigation method by using hysteresis current controller to controlling current through which we are going for demagnetization of each and every phase of excitation. One more work we are doing, like using optimization techniques. We are identifying the proper trajectory of vectors, which means that ripple is a matter of what are the switches you are going to tune in what time. So we are creating the creation of ripple itself is actually a wrong firing of the switches. So through the space vector modulation, we are identifying what are the switches to be optimized to avoid the ripple. So that is also we are using like vector optimization method. These are the 2 methods we are doing it. So we already published one paper in IEEE emerging paper. In that we are ripple optimization through the vector mapping we are done. And now IEEE transportation, one more paper got accepted. This is nothing purely about we use ANFIS and through which we are switching and we are doing a demagnetization immediately. Because by principle, SR motor is not an electrical motor, it's a power electronics motor. Because each and every time you have to excite a particular winding. When you create excitation, it is ready for your rotation. But once you complete that excitation, it has to be get demagnetized particular winding. But we are not bothering about get demagnetized. We are switching on to the next excitation. So because of it's not demagnetized, so it is creating a ripple. So our intention, what we do, we get demagnetized by using the additional vector induced. We are bypassing the current through the other phase. So automatically, the current ripple will be getting reduced. That is what we are doing through the ANFIS model through adaptive control method. So maybe you can search. Deepak is my student, so maybe Deepak and Bharatiraja, you can find out that paper. You maybe go through it, so you can find some solutions into it. So
sure, sir. Thank you.
That's what we are one of the area we are working. But there are people are working with different power electronics configuration also. But we are not working in that area. Probably we can work with only that conventional mid winding connected excitation, in which we are doing, but maybe some more techniques also, available in the SRM motor ripple mitigation. Yeah.
Okay, sir. Thank you, sir.
Any other questions, participants?
So there is one question in the chat box by Dr. Suraj.
Yeah, you can read our.
What will be the role of optimization techniques in EV design?
Which is design of EV.
Yeah, optimization techniques in EV design.
EV design, you're talking about the vehicle or any subsystem?
No, he has just posted in the chat box.
Okay, so suppose the five. So the question is very tough question. For example, you please understand. Maybe useful for all the participants. See, in EV means it is not new. First of all, for example, somebody asked the same question: what is the optimization techniques for the diesel lorry? The diesel lorry means the diesel engine we have to do optimization. Our spark plug we have to do optimization. Our exhaust we have to do optimization. Likewise, vehicle cannot be optimized. Vehicle motor is optimized. Vehicle battery is optimized. Vehicle controller is optimized. You got it? Probably the participants maybe reach out my answer. The optimization techniques everywhere you can achieve. For example, battery BMS or battery discharging characteristics, battery charging characteristics, motor power delivery characteristics, motor regenerativity characteristics. Maybe if you talk me wireless charger, again, misalignment characteristics. And if you talk about ADAS, properly you have to take your vehicle and do it in a proper path planning. So there you have to do optimization and energy management. For example, supercapacitor, battery, put together, putting in a power system in the vehicle, and when to the battery get charged, when to the battery get discharged, when the supercapacitor gets charged. All together, we are writing the algorithm to conserve the energy between the power system of the vehicle. So everywhere optimization is getting played. So vehicle design also you can actually optimize, but that is a mechanical engineer normally do that. The styling and vehicle structure, everything. And being an electrical engineer, electrical vehicle subsystem level, we have to do a lot of optimization.
There are no more questions.
I think we can close. I request Godwin to formally conclude the session.
Yeah. On behalf of the organizing committee and the participants, I extend a heartfelt gratitude to our esteemed speaker, Dr. C. Bharatiraja, for his valuable insights and inspiring presentation. Your vast expertise and passion for innovation have truly enriched the session, sir. I'm sure the participants have gained a deeper understanding of electric vehicle components, architecture, mainly EV chargers, and the initiatives of Indian government towards sustainable mobility. I'd also like to thank the participants for their active involvement, engagement, and made this session interactive and meaningful. Lastly, a big thank you to the organizers, technical team, and the leadership of B.S.Abdur Rahman, Crescent Institute of Science and Technology for making this faculty development program a grand success. With this, we conclude session 6. Thank you all for joining.
Thank you. And one more small announcement. I posted my WhatsApp number and as well as my email ID. If anybody wanted to visit our lab, you have to WhatsApp me and as well as you have to email me. Please fix your date, either any Friday or Saturday. Saturday very rarely, but Friday it's open to everyone. But the mandate email and WhatsApp is needed. We will be showcasing all our development and facility. Okay. So good luck to all the participants and good luck to the organizer and the coordinator for the rest of the session. Thank you so much.
Thank you, sir. Thank you, Gordon. Thank you for your valuable time.